Okay, so today we're going to talk about section 7.7, which is adding and subtracting polynomials. So really straightforward, what we're going to do today is we're basically going to add and subtract polynomials and get a result. So first thing that we're going to do is we're going to add and subtract what we call monomials. Remember, monomials are just a fancy word for saying one term. And so what we're going to do is we're basically going to add or subtract together a bunch of one-term polynomials. And so if we look at these, we probably have seen things like this before, and it's exactly what you might think. And what we're going to do is we're going to add or subtract like terms. So if we look at all of these problems, let's look at some certain aspects of these, and we're going to look for like terms. So like terms, remember, have the same base, they have the same exponent, and it doesn't matter whatever the coefficient is, it just matters what the exponent is and the variable, making sure that those are the same. So here we can see that 2s squared is a like term to 3s squared. And then we have just the plain old s all by itself. And so if we add these like terms, what we're going to end up getting is we add just the coefficients, which we get 5s squared plus s. And that's it. Then if we go to the next example, what we have is look for like terms. We have 4z to the fourth and 16z to the fourth. Those have the same variable exponent combination. And then we look at 8 and 2. But remember, when we're adding or subtracting like terms, what we should really make sure we're doing here is if we see any subtraction, get rid of it. It's going to make things a lot easier on yourself. So if we add the opposite here, now we see that we have a negative 8 instead of what looked to be a positive 8. And so if we add these like terms, we get 16 plus 4, which is 20z to the fourth, plus negative 8 plus 2, which is negative 6. And if we look at our last example, we can see here we're still looking for the same variable exponent combination. And if we have sometimes that we get multiples, so we have multiple variables, multiple exponents, remember this is still one term. And so we're looking for the variable exponent combination that's exactly this. So as long as we have b to the third and c to the second, then it's going to be a like term. And if we look at each one of these terms, these both have b to the third, c to the second, so that these are going to be all like terms. And again, don't forget, add the opposite. And so what we come up with is we have 9 plus 5 plus a negative 13. Well, 9 and 5 is 14, plus a negative 13 gives us 1 times b to the third times c to the second. Now let me ask you this. If I told you that I had 3c to the second, b to the third, is this still a like term? Is this still a like term? Well, yes, this is still a like term because it has the same variable and exponent combinations. We have a c to the second, b to the third, so do these. And so they're exactly the same. Because remember, with multiplication, we can write these in any order. And so if I switch these around, which I can do, you'll see that those are exactly the same. The next thing that we come across is when we actually start to add polynomials. Now remember, polynomials has different terms, and if we look at these, each one of these have a different degree, and so that's what makes it a polynomial. And you can see that this is a polynomial with degree 2, so this is second degree, and this is also a second degree, and we can also call those quadratic. Now we can add these things in two different ways. We can have the vertical form or the horizontal form. It doesn't make a difference. As you'll see, we'll get the same exact answer. So if we line these up, in which our variables are in the like columns, so if you see here we have the x squareds, the plain x's, and the plain numbers. These are all in the same column. And then once we get that, we can just add down and get 7x to the second power plus 9x plus 3. Now this might remind you of when we did solving systems that we just added down. It's the same kind of format. We're just adding two things together and getting the result. When we do it over here, what we need to look for is once we're adding, once we have that addition, we can just look for like terms. So let's look for all the like terms. Well, the first set, you have 5x squared and 2x squared. The second set you have 4x and 5x. And then the last set you have your number 1 and the number 2, which are all like terms. So if we add those like terms up together, 5x squared plus 2x squared gives us 7x squared. 4x plus 5x gives us 9x. And then 1 plus 2 will give us 3. And as you can see, both of these answers are exactly the same. And so it doesn't matter which form you want to use, you can use either one. Okay, so let's look at one more example. And so if we do this example, what we're going to look for is we're going to look for addition. Since we have addition, we can go ahead and add. I want to make one more change here. I see this subtraction. I really want this to be addition because it's just going to make life a lot easier. So if I rewrite this problem, well, if I look for like terms, I guess, I get 4m to the second power, m to the second power. I have a 5, let's use a different color, 5 and 6. And then I have this guy over here. I have this m, or negative m. It doesn't have a like term, but we still have to include it. So if we go ahead and add these, we could get 5m to the second, because remember there's that invisible 1 that's in the front of all variables. So 5m, so we have 4m plus 1m. Then we have plus negative 1m, because remember that here, and remember how we write polynomials, the degrees going from largest to smallest, and then we have plus 11, because we have 5 plus 6. If I was to do this in the vertical format, I would have to write out each piece. So I would have 4m squared plus 0m plus 5, because remember this is just nothing, but when I line these up, I get plus 1m squared plus negative 1m plus 6. So that way I have all three terms all ready to go. And so I get 5m squared plus negative 1m plus 11. And again, my two answers are exactly the same. Like I said, it doesn't matter which way we do it, as long as we're still looking for like terms. Now on to subtracting. Now with subtracting polynomials, there's one thing that we've talked about all year that we have to remember to do. And of course, that is adding the opposite. So if we add the opposite, we change our subtraction into addition, we can make this an addition problem, which we just learned how to solve. So if we change this into subtraction, or change the subtraction into addition, this is the subtraction that we're talking about right here. Okay? This stuff over here, yes, inside the parentheses, we still want to change that. So we're going to go ahead and do that real quick. So we're going to add the opposite here, add the opposite here. Now, but what we want to really make sure that we're doing is this subtraction in between the two polynomials. So if I add the opposite here, what this does, if I rewrite this problem, gives me 7m to the fourth plus negative 2m squared plus negative, in parentheses, 5m to the fourth plus negative 5m squared plus 8. Now you're thinking, okay, well what does this really mean? Well remember, we have that imaginary 1 outside of here, and it's being multiplied by this entire parentheses. So whenever we have a number out front of a parentheses, what do? Well, we distribute. And so distribute means to multiply that number out front by everything else. So once I do that, I rewrite my problem again, 7m to the fourth plus 2m to the second power plus negative 5m to the fourth plus negative 1 times negative 5 is 5m to the second plus negative 8, because negative 1 times 8 is negative 8. And then I can go about this the same exact way that I did before. So like term m to the fourth, m to the fourth, m to the second, m to the second, and then I have over here just another constant, which I don't have any other constants, so I can go ahead and add my like terms. So 7 plus negative 5 gives me 2m to the fourth. 2m to the second power plus 5m gives me plus 7. Whoops, made a mistake here. We forgot our negative, so this is a negative 2m. So really this is going to be a 3m to the second power. So we forgot our negative up here. Still carries down. And then plus negative 8. And that's our answer. So as long as we can convert the subtraction up here into addition and then multiply everything inside the parentheses by negative 1, we're good to go. So let's look at a couple more examples before we finish up here. So what I want to do is I want to convert all my subtraction into addition. So add the opposite here and add the opposite here. Again, what I can do is I can multiply this by negative 1 by everything inside. I can kind of do 2 steps in one, since I know I'm going to have to do it anyway. And so my new problem for addition is 2x to the second power plus negative 3x to the second power plus 1 plus negative 1x squared plus negative 1x plus 1. Okay, pretty straightforward. Now you're looking at me, hey, I've got like term here, and a like term here. I've got a positive 1, and over here we forgot our negative again. Negative 1, and then my last like term is just the negative 1x. If I look at this, I can say, well, positive 1 and negative 1, those are just going to cancel each other out. So I don't even have to worry about those anymore. If I go ahead and add like terms now, I have 2 plus negative 3, which gives me negative 1, plus one more negative 1 gives me negative 2x squared. And then plus, I still just have this left over, negative 1x. And then that's my answer. And finally, if we go to our last example here, we can write this in a different form if we want to, but first we need to add the opposite. So add the opposite, add the opposite, add the opposite. And then here what I can do is I can multiply by negative 1 to each thing, to each term. And so my new problem is 9q to the second power plus negative 3q plus 0 plus negative 1q to the second power plus 0q plus positive 5, because negative 1 times negative 5 gives me positive. Now the reason I added these zeros here, so the reason I added the 0 here and the 0q here is because I wanted to write this in the vertical form. And so if you're missing a term in between, you can always add it with a 0. And so if we add these in columns, we have 9q squared plus negative 1, which gives us 8q to the second power, plus negative 3 plus 0, which is still negative 3q, plus 0 plus 5, which is 5. And so there's our answer there, and we're all set. So the one thing that we just need to make sure that we're remembering is that we change all our subtraction to addition and then just add the polynomials together. Because if I can add together 2 polynomials, I can subtract 2 polynomials. I just have to make sure first I add the opposite. So remember 2 things. 1, add the opposite. So once we do that, once we change all our subtraction to addition, we'll be good to go. And then the second thing is distribute the negative 1. So now that we added the opposite, we're going to have a negative 1, and we want to distribute that to the rest of the parentheses. And it's always going to be the second set of parentheses. You'll never have to distribute the first unless there is a number out in front of those. So if you would like to, you can go ahead and go to section 7.7 in your book, which by now you should have downloaded the book. If you haven't downloaded the book yet, as far as the chapter is concerned, you need to. So go to section 7.7 guided practice, and you can do there numbers 1 through 15. and just do the odds, because with the odds what you have is you have the little blue button that has the number on it, and then it'll work the problem for you. And that way you get a little bit more practice so that you're ready when we come to class.